Today I want to talk to you about blockchain and the opportunities it provides to us in terms of digital signatures, PDF documents and workflows. First, let me do the needed marketing bit. This is the iText team, taken right before a team building event, so everyone's looking rather happy, and very diverse backgrounds, which leads to a lot of different add-ons, and it means that we spend a large proportion of our time doing R&D in different topics, and blockchain happens to be one of them. So why are we interested in blockchain? Typically, the things that you want to know about a document are these three. You want to prove integrity, so saying that if I sign this invoice or if I have this invoice, I want the person on the receiving end to have the exact same invoice. I don't want them to be able to modify the data, or I don't want a man in the middle to be able to change the data and then pass it off as an invoice that I sent. There is authentication, saying I created this content and I can prove that I was the original author. And then the third one is a right that is granted to end users, saying this person created the document and I can prove that they did it. So me being the author, I can't refute the fact that I created it. Now, when we think of blockchain and its solution towards digital signatures, most of this presentation can be summarized with this idea. So if you ever get lost in the presentation or you are uncertain about what I'm talking about, this is the essential core idea. So I've created a certain hash value on a certain timestamp, and I'm going to log this as a transaction in a blockchain. I'm going to upload the hash value. I can maybe sign it, and by doing that, I'm essentially ensuring that there is integrity, that there is authentication, that there is non-repudiation, and that it is automatically time-stamped. Now, this is just the basic level of protection, so to speak, that you get. Obviously, there are certain advantages to using a blockchain approach that only a blockchain can offer you. And it is about these advantages that this talk will mostly be centered. Before I delve too deeply into technical content, I just want to ensure that we are all talking about the same concept. So when I talk about hashing, it turns an arbitrary block of data into a fixed size bit string. It can be used for verification of data integrity. So when I hash a document, only the exact same content ought to give me the exact same hash. There are various hashing algorithms, SHA-1, SHA-2, and some other algorithms in the wild. Second is encryption. So when I talk about encryption, I mean specifically encryption with two keys, a public and a private one. The private one, as the name implies, ought to be private to only you, and the public one can be shared with other people. By having this combination of keys, you can do things like I'm going to encrypt the data with my private key, and since my public key is available to you, you can decrypt it again. And because only I have my private key, you are automatically ensured that the document was generated by me. And if we do it the other way around, it means that I can make sure that only you can read the document. How is this related to PDF? As you undoubtedly know, PDFs can be digitally signed, but there are certain things in this signing process that we take for granted that turn out to be drawbacks, and in reality they needn't be. So if you sign a PDF in a conventional way, it typically requires a certificate authority. As I've mentioned before, we have a public and a private key, and ultimately you need somebody to prove that your public key actually belongs to you, the physical entity. And we typically trust a certificate authority to do that. This is done in a hierarchic way, where one person has the authority, spreads it across people he or she trusts, and so on. Digital signatures at the moment also require a centralized time server. This is important if you're signing contracts or invoices. We obviously want the date to be correct, so we can't use the local system time because that can obviously be tampered with. So we need some central authority to say this is the actual time at the moment. Now, due to the way the specification is written, you cannot sign a PDF in parallel. Whenever you sign the document, you are essentially creating the hash value of everything in it. And that means that if one person has already signed it, the document has changed because now you've added a signature. And that means the second person has to sign a different hash value. Even though this is theoretically secure because you are signing off on the signature of your predecessors, it also means in practice that documents with very long signature chains don't really happen that much. We've seen cases where a bank needed, I think, 5 signatures from their board of directors, and somewhere halfway through, they noticed that Bob had gone on vacation and that he couldn't sign. And so now you have one document that is emailed to 2 people, the other 2 people have signed a different version of the document, and it's impossible to merge them, and it's impossible to get all of these signatures back into one document. And the key problem here seems to be that the signatures live in the document, that we need the actual document in order to be able to sign it. And this is very counterintuitive to what we are seeing nowadays in the real world. We've seen in many previous years that we've gone from physical paper to an electronic document, so the dematerialization of paper, and now we are slowly getting towards a situation where we're dematerializing the document. You no longer need an actual PDF document to board your plane, you need the QR code to do it. You no longer need the actual certificate of the bank, the hash value might be enough. Because like I said, who is going to be able to recreate it and who is going to be able to reconstitute your document given the hash value? So what are the opportunities that are specific to blockchain? Essentially, when we think of blockchain, we can think of it as a way of storing binary data and mapping it to a certain key. So when we do that, we can, of course, sign this binary data using any known signing infrastructure. It can be automatically validated and time-stamped, and that's not even getting into smart contracts that are available. It can be viewed by everyone who has access to that blockchain. So if you have a public blockchain, it means that your transactions and your data can be verified by a large amount of people. If you prefer your blockchain to be private, which is something that is typical for banks or companies that deal with confidential data, you can also limit it to a private blockchain, and you can ensure that it can be viewed by everyone within your organization rather than everyone. But the key takeaway is that your signature doesn't need to be in the document anymore. Essentially, all you need is the hash value and a reference to the blockchain where your document is being stored. So on a high level, let me walk through a use case. And in the back of your mind, you can imagine an invoice being created and a typical workflow for somebody ordering a product. The invoice is created, they receive the product, they sign off on the invoice, etc. So we have the initial creation of the document where somebody says, okay, you've ordered this thing online and you are going to pay this amount. The ID of that document gets registered on the blockchain. So the blockchain now knows the hash value of the document, it automatically timestamps it, it has the ID. Bob wants to sign the document, the delivery guy is standing in front of Bob's door, and Bob needs to sign off on the fact that he actually received it. So Bob's private public key infrastructure is used, he signs off on the hash value, and his signature is added on the blockchain. Blockchain is an immutable ledger, so from this point on, Bob will always have signed off on this document. He can no longer take the information back, and afterwards we can always prove that at this specific moment in time, Bob signed. Of course, at some point something goes wrong, and Alice wants to know whether the delivery actually reached Bob or not. So she wants to know if Bob has signed off on the document. So what she can do, she no longer needs the physical document, she no longer needs the actual PDF. It's enough for her to have the hash value of the original PDF document. And she can say, okay, I'm asking the blockchain, given this key, can you output me all the records related to this particular key? And she will, of course, see the entire chain. She will see the document was initially created at this timestamp. It was registered there. It was in our warehouse at that point. The delivery guy signed off on having packaged it, and Bob signed off on having received it at this point in time. And again, none of this data can be mutable, so there is no trace or no hint of forgery. So she checks the blockchain and she finds the ID that matches Bob's key. And she, of course, has Bob's public key, so she can say, okay, Bob has signed at this particular point in time. Now, on a more detailed level, like I said, because this is new technology, because there is currently no specification for this, we can store any amount of binary data on this particular blockchain that we want. So we are not bound to the usual cryptographic envelope. We can store the ID of the document, the hash value and its algorithm, the signature and the algorithm generated, and the algorithm used to generate it. But we can also add fields that are chosen by the end user or by the application that does all of this work. So we can now add workflow information. We can say this invoice is awaiting feedback. We can say the asset has been checked by customs. We can say Bob signed off on it. And we can say Bob's bank decided to have the payment go through. Now, a key part of all of this, one of the reasons why we are interested in this, is that society is moving away from central authorities. We no longer trust people as easily as we did before, and we prefer a more distributed way of trusting people, a way that seems more resistant to error. So one of the concepts that I would like to introduce here, and that matches very nicely with this idea of blockchain, is a web of trust. So when we are talking about a web of trust, we say it is a way of establishing an authenticity between a public key and its owner. So it essentially solves the problem of dealing with certificate authorities. Instead of having to say this person is trusted by iText and iText is trusted by Adobe and so on, we can say this person is trusted by all of these other people. And 50 of those people happen to be your personal friends. So it is up to you to choose whether you want to trust them. You can automate it, but we can give you a degree of trust rather than a simple black and white. So how does this work? Bob can look up the public key of Alice, or Alice can simply hand it over to Bob. They can meet at an event like a key signing party, but we can assume that Bob has access to Alice's public key for some reason or another. Bob can then use his private key to sign Alice's public key. And again, he puts this information on the blockchain, not necessarily the same one that is used for documents. You could have a separate blockchain that just deals with trust and one that deals with documents. But Bob uploads this binary information to a blockchain. That means that all other users can see this record. And again, all other users could mean everyone that has access. It could mean everyone within the same company. They can verify, because they know Bob's public key, that Bob has signed Alice's key, and that can be considered Bob trusting Alice. Now, by doing that, we build a graph where certain people are trusted by other people. And this graph is not directionally connected. It doesn't show a hierarchy, but you can imagine that in a company setting, you could have the CEO trusting the board of directors, you could have the board of directors trusting certain managers, and trust trickling down that way. The application built on top of such a framework can decide how to handle trusted versus untrusted users, and more importantly, it can assign degrees of trust to people. It can say, Jane is trusted by 3 other people within the organization, but I've noticed that on average, other people are trusted by 20 people, so Jane is less trustable than these other people. I think we all know this example screenshot, or at least the concept within it. At the moment, it simply says signed and valid. The proposed solution could say valid and signed and person checked by so many people, or the person is trusted to a certain degree, or trusted by so many of your direct contacts. Furthermore, like I said, we can add any amount of binary data to it, so we can add extensions like typical HTTP protocol or TCP protocol, I think. We can add acknowledged or not acknowledged to a signature. We can say Bob can revoke his trust starting a certain date. And this is non-trivial. It means that in a corporate setting, Alice can be trusted for a certain amount of time, then she leaves the company, and we can revoke trust in Alice. And because we are building a graph, and because the application can check the entire graph, this small change can immediately percolate down, and other people will immediately see, okay, Alice is no longer trusted. So this allows for temporary trust, and that's useful for interim workers. Let's go through an exact use case that I hope will clarify most of these concepts. So this is a container ship in the port of Antwerp. And the problem with the port of Antwerp that they were experiencing is that containers go missing, or rather the content of containers gets stolen. And this is not surprising because containers are often locked with a physical digit lock, and that means that somebody has to know the code to this lock. And in fact, when we looked at how many documents are exchanged, when we looked at how many parties are involved, it typically takes about 30 people and about the same amount of documents in order to transfer a single container. You have to have people checking the goods before they go in. People have to sign off on the fact that all of them are in the container. Every time the content gets moved from one location to another, it has to be checked, and so on and so on. And all along this path, everyone exchanges the security code of this container in various insecure ways, going from faxing the code to one another to simply putting a post-it on the fridge and saying, okay, the container that's coming in at 3 has this code. If you need to check it, that's the one. That's the sad thing, that it actually happens. So like I said, a lot of documents change hands. Some of them are electronic documents, some are paper documents. Some ports are making a genuine effort to go entirely paperless, and that's very commendable of them, and it will certainly help traceability. The problem, like I said, is the fact that this code is known by everyone. And that means that if some content of the container goes missing, we can no longer say who's to blame. We can't assign responsibility because we don't know who actually had access to the container at a certain point. Now, the solution to that is, instead of passing around these paper documents, or instead of passing around electronic documents and signing them and having them get lost in email, we can sign records in a blockchain. And that means that as soon as you sign off, we know that you signed, we know who trusts you, and we know that the container from that moment on belongs to you. If anything goes missing, you are responsible. And even though this doesn't physically stop people from stealing, the fact that you can assign responsibility in a very clear way means that people are very demotivated to steal. So what is the roadmap for the blockchain world and the PDF world? If you look at the PDF community, and in particular a typical PDF company, there is a lot of expert domain knowledge. People are very knowledgeable about PDF and its standards. People typically have a large amount of experience with PDF and software. Various organizations are part of the ISO committee, so we set the standards that we adhere by. In a certain sense, that's the policing itself. And developers in these companies are highly trained in a niche market. Now, if we look at the blockchain community, there is still a substantial amount of investigation to be done. You have a large amount of startups, and everyone has their own idea of what will be the next beautiful idea that will revolutionize the world. There are a lot of patents involving blockchain, and some patents involving blockchain PDF interaction, and some more abstract involving blockchain and physical objects. There is one use case in Antwerp where a company called Everledger wanted to ensure that diamonds are real and not blood diamonds, and so they made a hash value of the physical diamond object, and they uploaded this to a blockchain in order to be able to trace it. And apparently a jeweler can do this so accurately, verify the attributes of a diamond so accurately that this hash value always matches only one exact diamond. So like I said, a load of startups, a load of interesting ideas and patents, and people thinking that they have seen the light. And I think there is an opportunity for mutually beneficial cooperation. These people can learn about the possibilities of electronic documents, and in particular about PDF documents. And we can learn how a blockchain can be used. We can improve ourselves just as much as they can improve themselves. Now, before ending this presentation, I want to give a disclaimer. This is, for those who know it, the Gartner hype curve. And they posit that every new technology is somewhere along this curve and will evolve over time somewhere along this curve. So you have a very slow early adoption rate. Then people start to evangelize it, and it gets into a giant peak where everything absolutely has to be done with this technology. Then everyone comes down from the expectations, and it turns out that in the end there are still quite some use cases that actually happen to be useful to do with this new technology. And for blockchain, we have to make no illusions and no assumptions. We are still very much on the peak of the curve. So only time will tell whether certain technologies and whether certain ideas happen to be a hype or happen to be veritably a good idea. Now, this is an event with a lot of PDF vendors and people writing the specification, so I would also like to reach out to you. How can we help each other, and how can you help this technology move forward? What we have done is gather use cases. It is incredibly useful to learn how people are using PDF documents, digital signatures, and especially how people are misusing digital signatures in the real world. I think we also ought to have a look at what we can do from within the PDF Association to look at new technology like blockchain. What is our official opinion on this? Maybe we can make drafts towards a specification. From an iText point of view, we have an amount of code that demonstrates a proof of concept. You are always welcome to do a pull request. You are always welcome to discuss these ideas with us. I think that together we can learn and together we can improve. Are there any questions? Yes.